If a developer I'm working with asks, "Why did you select that font?" it's pretty unlikely they'll accept self-preservation as my answer. Type designer Pierre Haultin may have actually been able to get away with this claim. He lives and works in Paris during the mid-16th century, printing books and designing type. And how the type he designs performs, how efficient it is spatially on the page, is actually much more relevant to his personal safety than it is for his contemporaries. The work of type designers today, people who design fonts professionally, is still historically linked to these 16th century craftspeople called punch cutters, like Haultin. While typefaces designed or revived more recently, ones you might be using on screens today, probably started their life as a sketch and then were worked on digitally quite quickly, a book typeface made in the mid-1500s starts its life in steel. Having the ability to print, publish, and design type in this matter affords Haultin a more active role in what we might now call the design process. His skills enable him to explore issues of typographic efficiency through the design of type itself. Centuries on, it's no longer the punch cutters or the printers or even the type designers who are solely responsible for the performance of type. This group has expanded to include typographers working on the web. And whether you see yourself this way or not, you probably are a typographer. While type designer is the name given to the designers of typefaces themselves, typographers are the people who use them. This means that designers, developers, writers, or anyone replying to tweets instead of listening to my talk are setting type in ways that couldn't have been anticipated back when it was being cut out of metal. And whether we take on the title graphic designer, front-end developer, software engineer, or something else entirely, we still have a similar question to the 16th century punch cutters. How might a text be received and read more efficiently? We can continue to suggest answers to this on the web by making the most of the existing practices we have, taking advantage of upcoming technologies, and using the punch cutters process as precedence for designers having a role in web performance. Depending on how long you've been working with fonts on the web, these may not exactly sound like new challenges to you, but relatively speaking, Haultin's are even older. He's working on the Bible. Historically, religion has driven lettering, type design, and a great deal of communication in general. The first mechanical movable type printing press was printed by Johannes Gutenberg 100 years before Haultin's working. And as he prints the iconic 42-line Bible, it becomes the fastest book ever produced. So what could possibly make printing a Bible a worthy challenge for Haultin, someone so skilled, an entire century later? Certainly, he knows how to create effective work, and this is not where his problem lies. His ability to print, publish, and design type means he's more than capable of working on a new version of the Bible. No. Haultin's requirements come from a secret that he's keeping. In addition to being a printer, a publisher, and a proficient punch cutter, he's also a Protestant. Protestantism is essentially a forbidden branch of Christianity during the mid-16th century. Its members are known as Huguenots, though Haultin's managed to keep his own beliefs a secret up until this point, largely for his own safety. Through improvements in printing technology and secret promotional efforts of people including Haultin, Catholics are increasingly converting to Protestantism in Paris, and this does not sit well with the most powerful Catholics in the country. They're unimpressed, and they impose a religious repression upon Paris, one that steadily worsens under the newly crowned King Henry II. Now, this is a religious disagreement, and I'm sure there's plenty of people who could be blamed for it, but it's hard not to see the king as the person in power, as the villain here. He gets a lance through the face about 3 years from now, if that makes you feel any better. Jousting tournaments, you know how it is. But in the meantime, this is the position that Haultin finds himself in, with a desire to practice his faith, but he's facing death in doing so. Like many designers and developers today, Haultin builds his own tools to solve his own problems. And as the religious climate in Paris grows worse for Protestants, so do Haultin's concerns with the design of the Bible itself. I first became interested in his story through the books The Paleontography of the French Renaissance by H.D.L. Vervliet and Counterpunch by Fred Smyers. In the latter, Smyers speculates what's going through Haultin's mind at this trying point in his life, but I prefer to think he would have asked God more directly. "Why do people keep making these large and heavy Bibles?" he probably prayed. "I need to be able to pick up my things and move quickly. I don't want to be discovered practicing my faith, but how might I make these books smaller?" Thinking through this, or divine intervention, depending on your perspective, leads Haultin to design what could be considered the first French-language pocket Bible. He's constrained by how small the type can be while remaining easy and desirable to read. Its spatial efficiency on the page determines how physically small this Bible can be. A typeface that reads well at small sizes means less pages to print, a more economical number of characters per line. And Haultin approaches this problem by experimenting with the extreme ends of the parameters he wants to design within, something that's still common in type design today. Here, a fairly bold weight of a typeface and a fairly light weight have been designed so that the middle weights can be interpolated in between. This is a common practice in type design. And working with these extremes is something that Haultin does as well. He's actually technically skilled enough to cut a typeface that's too small to be able to read properly, but by overshooting his boundaries, he's able to find new approaches. And this is incredibly difficult. Remember that 10-point type is a physically different object than 12-point type. Haultin's working at scale. He has no vector tools to help him zoom in. He has to actually make this by hand. He's able to test his decisions along the way by doing this as well. He holds his tools, his molds, his punches over an open flame, covering them in soot, and presses them into parchment. And he eventually finds the spatial sweet spot for this book typeface and can print a gorgeously inconspicuous Bible. Haultin's performance issues in type design mirror our own performance issues on the web. How might a text be received and read more efficiently? He suggests answers to this through the design of type itself, but that's not the only place this question needs an answer. We're still facing issues of typographic efficiency today, but less often they are in the Bible and more on the web. However, you may be referencing fonts on the web, manually hosting them and writing your own font face declarations, or using a web font service like Typotech, Typekit, WebTypeFonts.com, Google Fonts. It's clear you are referencing more fonts. The adoption of FontFace and WAF, the web open font format, has been rapid. These services also make it less likely that you're writing these font face declarations manually, but when you drop in a CSS or JavaScript snippet from one of these services, you're still getting a style sheet like this back. So let's just quickly review how font face works together with WAF files and CSS. First, we specify the font family name that we want to be able to use elsewhere. Then we specify the font style, the default font style for that declaration, which in this case is normal as opposed to italic. Then the font weight, which in this case is 300 because that corresponds to the light weight of the typeface, which is the version of the WAF file that we're loading in. In 2009, the WAF format's biggest challenge was adoption. Its goal was firmly establishing a true way to use fonts on the web. And thanks to the hard work of the Web Fonts Working Group and many other people, it's safe to say that this has happened. There's been a huge increase in web font usage from 1% at the end of 2010. Actually, this doesn't seem sufficient. OK, to 50% of sites are using web fonts at the beginning of this year. And I think the poster child for this is OpenSans, a typeface release in 2011, but it's now more common than Lucida Grande on top sites, which has been a commonly sanctioned web-safe font in some settings. And here's some things that happen less often per day than the number of times OpenSans is served. Streams of a top YouTube video, the number of Facebook photo uploads in a day. 500 million tweets in a day is a lot, but it doesn't really come close to the 2.45 billion daily OpenSans font views that Google Fonts reports. And this doesn't even factor in the self-hosted versions or versions hosted by other web font services. Now, keep in mind, I'm about as much of a statistician as I am a French religious historian, which is to say that I'm only interested in it when it relates to typography. But I guess the point that I'm really trying to make is chill out with the OpenSans. Oh, yeah, and maybe this, that we can really call web fonts and their adoption a success, but we've also brought along some performance issues because of this. We're building sites that request more fonts. We had an 8 kilobyte average in 2012, and we've gone up to a 59 kilobyte average by the end of 2014. And to mitigate this, most font face generators and font services subset fonts, removing any characters that are deemed to be unnecessary, regardless of what the type designer originally intended. While subsetting is often worthwhile, it also imposes many limitations that aren't immediately obvious, and this is what concerns me more. This is something I discovered while working on Normalize OpenType.css, a style sheet that, like its namesake Normalize.css, aims to provide sound CSS defaults across browsers, but specifically for advanced features included in fonts that are often ignored. With Normalize OpenType.css, you can replace collisions like this between the F and the I with a beautiful ligature that's included within your font instead. And in headings, you can also enable discretionary ligatures to have a bit more of a flourish for titles. When you have abbreviations in your text, you'll often have multiple uppercase letters in a row, but this can be distracting in long-form reading and draw your attention away from what you're supposed to read next. So Normalize OpenType.css will take advantage of small caps, which actually line up more with the lowercase letters. This is also true for numeral styles. And you can see that the old style numerals will actually line up with the lowercase letters rather than the uppercase. And there's a bunch of other features available as well. Here's an example of them in use in the Vancouver Typography Meetup website. Other features also enable you to take advantage of features in script typefaces. This is James T. Edmondson's Lavanderia from Lost Type Co-op. And this is the same typeface, but by changing the features that we're using, we can actually create a very different character from that typeface. Some languages actually require OpenType features to display properly, and that also needs to be taken into consideration. Because in practice, those browser inconsistencies I was worried about with Normalize OpenType.css turned out to be a less common problem than those ligatures, alternate glyphs, and other design considerations being subset out before they ever reach your browser, before you can ever use them in your CSS. We're expecting more and more in type on the web, but aggressive subsetting means cutting a typeface down only to support certain languages by default. And while it's not practical to say that we should include everything, it's an issue that we need to be aware of. When writing and speaking about performance problems on the web, ones like these, it's often common to present them only within their immediate context. But the truth is that many people have been working on problems like this for a long time, and many of those people were actually designers. We saw how in the mid-16th century, Haultin solved inefficiency through his space-saving workhorse metal typefaces themselves, but our current technology renders the same point of intervention less impactful. This discovery was shared by Matthew Carter, a highly respected type designer, most well known for making both Georgia and Verdana, so I imagine you're familiar with his work. When he spoke in Vancouver, he mentioned the need for efficient type in the mid-1980s, where serif fonts were taking up a lot more data than other typefaces, and the memory on those devices was extremely limited.
I made a serif type, you can see it on the right, without curved serifs. I made them polygonal out of straight line segments, chamfered brackets. And look, as economical in data as a sans serif. We call it charter on the right. So I went to the head of engineering with my numbers, and I said proudly, I have solved your problem. Oh, he said, what problem? And I said, well, you know, the problem of the huge data you require for serif fonts and so on. Oh, he said, we solved that problem last week. We wrote a compaction routine that reduces the size of all fonts by an order of magnitude. You can have as many fonts on your system as you like. Well, thank you for letting me know. I said, foiled again.
Matthew Carter still goes on to design an amazing typeface using those constraints, but it is true that the engineers managed to compress every font on the system. Yeah. We're now in a similar position on the web. The designer has a role to play in web performance, but solving our own performance problems within the type itself, as Haultin did, as Matthew Carter ended up pursuing for other ends, no longer has the same impact. The intervention must come from the system, not from within the implementation of the individual font. Thankfully, the Web Fonts Working Group knew exactly this, and with the adoption of WAP, they were able to turn their attention to refining the existing implementation, and the result of their work is aptly named WAP 2. From a technical perspective, it sounds a little bit too good to be true. What if you could continue to use the same interface for loading fonts you're already familiar with, font face or a web font service, but soon you could expect the font files you requested to be significantly smaller in file size? Well, this is actually possible because of a Brotli compression algorithm applied to WAP 2 files. Brotli is a generic purpose lossless compression algorithm that uses a bunch of compression techniques that I will probably never understand in my lifetime. It provides denser compression than WAF while maintaining a good decompression rate even on mobile devices. But what we're interested in as designers and front-end developers is the outcome for our end readers. While testing this, the Web Fonts Working Group ran various font catalogs through this new algorithm, and they found a 14% compression improvement rate on Typekit's TrueType font catalog, and a 27% improvement on the remainder of the catalog. That was mirrored in the monotypefonts.com catalog, where they saw a 25% improvement, and non-Latin typefaces, the best observed compression rate was a 60% improvement. So I think there's significant potential here for non-Latin scripts and loading typefaces in other languages on the web more successfully. One of the best things about WAF2 is really one of the best things about font face. The font face specification cleverly anticipated the need to support multiple formats simultaneously. So even though WAF2 is new, there are actually no changes to the syntax within the CSS itself. To continue with this example from before, you may have seen this feature of font face used to provide fallback fonts for older browsers and devices. Here, we're loading in an embedded OpenType font for much older versions of Internet Explorer, or ignoring some quirks for the sake of simplicity. But when the browser doesn't support that, it'll fall back to the WAF file. We can also add another declaration and fall back to a TrueType font file for older versions of Android as well. Now, in practice, unless you have very specific device support requirements, I don't think you really need to worry about anything except WAF anymore. But in the exact same way that we fell back to those older formats, we can optimistically support new formats as well. In this example, if the browser supports WAF2, the WAF2 file will be requested, and if not, we'll fall back to the WAF file, the original flavor, instead. And if you're using a service to provide web fonts for you, a CSS file similar to this is already being generated when you drop in a link tag like this. And that's what's being requested. So it also means you might be trying, or you might already be using WAF2 today and not even realize it. At the end of 2014, Google Fonts started experimenting with this for some of their non-Latin scripts for their early access fonts. This is Open Sans Hebrew. When you drop in the JavaScript snippet they give you, you can see it's actually just requesting a CSS file. And when you go and inspect that CSS file, you can see they're presenting the WAF2 files ahead of the WAF files. And they've gone on to expand that program across all of Google Fonts. So if you're using Google Fonts, you're actually already loading WAF2 files if the browser supports it. Now, if you're self-hosting your web fonts, you can generate WAF2 files as well. Google has their library available on GitHub, and you can convert any TrueType font into a WAF file. Or if the command line version isn't as appealing to you, you can also use some things like Font Squirrel. Just keep in mind the subsetting issues that we talked about when you're choosing the other options. But these will let you convert to and from various font formats. Now, if you are self-hosting fonts, it's important to check your license and see what that allows. Fonts are software, and it's important that we know what the license permits. But many foundries and distributors are actually run by fairly small, personable teams. And getting in touch with them and asking for them to build you WAF files isn't unrealistic. I know it doesn't scale, but hopefully by asking them for these WAF2 files, it'll be a problem we don't have to worry about as much once more interest is shown. It's also just a great excuse to talk to the person who designed your fonts. Now, browser support has been one of the only drawbacks of WAF2. It's supported since Chrome 36 and Opera 23 and Chrome 37 on Android. But as of a few days ago, Firefox has it enabled by default as well now. So I'm super excited about that because it's no longer just under a development flag. And IE's also marked it as considered on their voting chart, which is more than I can say for Safari. WAF2 has good enough browser support is definitely worth taking advantage of if you haven't already. And hopefully we'll see more browsers, foundries, and services increasingly make use of WAF2 files as well. But this might make it seem like the performance of web fonts is purely an engineering challenge. As Matthew Carter discovered, software engineers are capable of making these massive performance improvements at the level of the system, sometimes rendering our one-off improvements seemingly unimpactful. But I see WAF2 as an opportunity to reconsider what's really important. With WAF2 files dramatically smaller, there is an opportunity for designers and front-end developers to turn their focus to perceived performance and other client-side optimizations instead. So these are some things that you can do on your site that, in addition to loading WAF2 files, will make your site feel faster. My first recommendation is to stop using the CSS-only approach that web font services often recommend. They'll give you a link tag or an import statement, but when we want to consider perceived performance, it's actually better to choose what might be listed as the advanced option or the JavaScript option, where they'll give you a snippet like this, because this is going to give us the control we need to influence how the web fonts are loaded. And most of the time, this is actually using typekit's webfontloader, which is maintained by Bram Stein. And so even when you're loading in web fonts from different services, it's still probably using this snippet. So they're still probably using this library. So it's worth checking out using it directly. And as an exercise, I just wanted to show you some of the things you could do when you're trying to request fonts from various services. So let's load in Ross Milne's Charlie and Echo from Typotech, Nadine Shaheen's Frutiger Arabic from fonts.com, Elisa Nowak's Escapade from Type Together via Typekit, James T. Edmondson's Lavanderia from Lost Type, which we'll self-host, and then Yannick Yonsef's Open Sans Hebrew from Google Fonts. So if you wanted to load all these in separately, they'd probably each give you a JavaScript snippet, which is probably using the web font loader, a different version under the hood anyways. But by using this library directly, you can get the fonts you need from Google, typekit, monotypefonts.com, self-hosted fonts, and services that provide CSS style sheets, all in one configuration object. Now, of course, you wouldn't want to actually load this many fonts all at once, but the web font loader will also allow you to take care of that. So if we say Echo is our most important typeface, we can load that first, and then defer the other fonts until the other situations that we need them in. It's also possible to load the web font loader and the web fonts in asynchronously, and this is a really good idea because it provides the opportunity for a flash of unstyled text. And yes, this is an opportunity. As Tim Brown of TypeKit points out, our view of typography should still be centered on a principle of progressive enhancement, that a text itself is fundamentally more important than our suggestions about how it should be typeset. And this is painful for me as a typographer to admit, but the truth is that if we really want our type to be reflecting the content properly, we have to prioritize the content independently of the typeface at some times when the connection is poor. So the default async script looks like this, and it's available in the web font loader README. But you can also look at using the async attribute. And if you're looking for something even more cutting edge, ScotGel has written an amazing article about Bramstein's newer version of the web font loader, Font Face Observer. So if you're looking for something more up to date, I recommend checking that out. It's a bit lighter weight as well. In any of these cases, we've created an opportunity for this flash of unstyled text, and that means our content can load, and we're not necessarily going to wait for the fonts if you happen to be in some sort of situation where there's a really bad Wi-Fi connection for some reason. And additionally, the flash of unstyled text, as Bramstein says, is a feature and a condition that everyone should design and anticipate for. Some browsers until recently didn't even have a timeout for web fonts built in, so you could potentially be waiting forever if you chose to, which you wouldn't. So with the web font loader and Font Face Observer, you can set a timeout. The default is 3 seconds to wait, and at that point, you'll show the fallback fonts instead. But I actually recommend lowering it, maybe as low as 1.5 seconds. And the reason for this, or something that this means, is that font stacks still matter. This is something we, I think, have forgotten about in a lot of ways. When I see a font stack like this, it makes me feel like I just got a lance through the face. Because font family is a property that's always had graceful degradation built in, and yet we're ignoring that opportunity. When Google Fonts or other services recommend you web fonts, they usually give you the main font and then the category, and that's it for the entire stack. But if we're thinking about loading in the fonts asynchronously and using the flash of unstyled text to our advantage to make our page loads field faster, then we actually need a more compatible font stack. So in this case, I'm loading Trebuchet on Microsoft platforms, Droid Sans on Android devices, older ones that only have that. Futura, which is available on a lot of devices. It's not common, but it's good enough that we should use it. And Avenir Next on more recent iOS and OS 10 devices. So for a geometric kind of sans serif typefaces, which is what I've been using in the slides here, this is a great font stack and something that's going to be more reliable than just Soleil sans serif. And if you want to make use of that work again, you can actually map it to a variable in your preprocessor and reuse this across email newsletter templates you might be making. Web fonts are available in some clients, but their support is much, much worse than on the web. So it's important to have a really good font stack for email newsletters, and that's somewhere you could reuse that work. Pierre Haultin endeavored to improve spatial efficiency and enabled more contextually appropriate communication in his day. Though the issues driving our optimizations are not always dire, they are perhaps more relevant than ever. It's clear there's a need and a precedence for designers improving typographic performance problems. And by looking ahead to new technologies, WAF 2 and the inherent performance improvements that it brings, taking the opportunity to employ other established practices in the meantime, like using font family for a fallback font stack and the web font loader, we can make our own suggestions at how a text might be received and read more efficiently. There's precedence for designers' role in the performance of type on the web. Now, too often, the way we view and present our work, it can be easy to get caught up. That what we're designing and developing is entirely new, and I'm as guilty of that as anyone. But to me, there's something even more wonderful reminding ourselves that we're far from the first to try and improve our communication. Whether you're working on cutting the smallest readable metal type or just trying to make your fonts feel like they've loaded a bit faster. Thanks.